This is CGTN, China Global Television Network.
Computing power has become a key domain in the digital era as nations compete for economic growth and global influence.
China has already explored how to use the computing power to boom the economy.
Every penny of investment in supercomputing assets is rewarded with real money.
1 RMB invested in the computing power building will result in 3 to 4 RMB in total GDP.
CPU capacity doesn't seem to be keeping up with demand for computing power, suggesting that Moore's law may be failing.
Computing power can fuel the digital economy only when we have sufficient capacity of the internet infrastructures.
New processing units such as GPU and DPU were created to adapt to an evolving IT landscape.
We believe together with CPU, GPU, and DPU, we will have a much more balanced yet efficient computing infrastructure.
Future computing power is expected to realize our fantasy of AI worlds. But for now, how can we empower the digital economy by upgrading infrastructure? What role should government play, and to what extent should the private sector get involved? Only on BizTalk, only on CGTN. The pandemic has confirmed that more than ever, digital capabilities are essential to ensure a country's growth and economic resilience. A recent report shows a direct correlation between economic expansion and computing power by demonstrating that 1 point of growth in the computing index could translate to 1.8 per mil growth in GDP. Countries are counting more and more on digital development to pull their economies out of post-COVID doldrums and spark economic development in these turbulent times. Hello and welcome to this edition of BizTalk. I'm Guanxin in Beijing. Today we'll talk about computing power and how it empowers China's digital transformation. In the era of digital economy, computing power defines productivity. It has become an important new infrastructure for China. The country has recently announced plans to build new data center clusters in its western region to boost the nation's computing power to support China's digital economy development. To explore China's computing power infrastructure and how it empowers digital transformation, I'm joined by two distinguished guests today. Zhang Yu, Senior Vice President of User Technology, a data processor maker in China, and Yu Yan, Assistant Professor at the Institute for Interdisciplinary Information Sciences at Tsinghua University. Welcome to the show, gentlemen. Mr. Zhang, you are in the industry. Help us understand the critical role that computing power plays in China's future economic growth. How important is it to the digital economy?
Actually, there won't be a digital economy without computing power. As stated in the report, for US and China or any countries whose computing power index score is over 60, if the computing power index grows by 1 point, we would expect a 3 times relative growth in GDP. According to another computing power expert report from CAICT, the China Academy of Information and Communication Technology Institute, 1 RMB invested in the computing power building will result in 3 to 4 RMB in total GDP. So it is indeed very important to both digital economy as well as the whole national economic growth.
So there's a ratio of 1 to 3 or 4. Professor Yu, what is your understanding of this correlation? Why there are multiplier effects according to the report released by Tsinghua University?
We find that the digital economy actually booming because the computing power first can support very complex but very important public services. So the first thing is that the information technology revolution enable the algorithm to provide such kind of public services with a low cost. This is the origin of booming of digital economy. On the other side, in China, because China is a developing economy, we are not just experiencing the third industrial revolution. Actually, we are also processing the industrialization process, the urbanization process, and also the economic transition to more market-based. For example, the digital economy create a new norm of urbanization. Okay, in conventional urbanization, people move from rural areas to city for work. Nowadays, because the digital economy, people can stay in the rural areas and contribute their labor online. And if we open the TikTok nowadays, we can see many anchors selling the agricultural goods to cities, but they stay in the rural areas or small towns. Sometimes they stay in rural areas and small towns, but play the role of dealers of selling the good produced from one city to another city. So this is the way how this kind of digital economy or computing power contribute to the economic growth in China. China's example is a very unique example, but can show the experience how the digital economy help the developing societies to have more opportunities to boom their growth.
Data is a crucial domain in the competition for global influence. This indispensable resource is like the oil of the 21st century. Vast flows of data continually comes in from all human activity. The economic and financial sectors are no exception. However, the accumulated amount of data is piling up faster than business can organize it, and that's where government needs to step in. By providing high-performance computers, businesses will be able to better make sense of the data and extract more value from it. The digital industrialization base is becoming increasingly solid in China. A fresh report says that from 2021 to 2022, China's computing power increased the most among 15 nations surveyed and was second only to the United States. Professor Yu, according to a recent report on the evaluation of the Global Computing Power Index, China is ranked in the second place right after the United States. How do you interpret that? And what factors do you attribute to China's progress in computing power development?
First of all, I'm not surprised these two countries rank the top two of the computing power capacities, because these two countries are also the top two largest digital economies. Also, if we look at the artificial intelligence research or other research in computer science areas, we will find these two countries contribute the most part of the studies. All those kind of activities demand for computing power. So my first conclusion is that the market demand are the main driven force for the computing power expansion. We know that China has invested a lot on the internet infrastructures, and the computing power can fuel the digital economy only when we have sufficient capacity of the internet infrastructures. So this is another reason why these two countries have very flourished digital economy and why they have a very large size of computing power.
And Professor Yu, we have seen growing demand of computing power in the manufacturing sector. How will computing power empower China's new industrial upgrading?
When we're talking about industry, upgrading industry, we should be very careful, which direction we would like to upgrade to. The digital economy actually reshuffle, the value distribution over the supply chain or the value chain. For example, imagine before the e-commerce platform, we have the factories, we have the consumers, in the middle we have the dealers with brand. So most of the profit are gained by the middle side, by the dealer. However, with the e-commerce platform, we use algorithm to matching multiple buyers with multiple sellers. In this way, the e-commerce platform, decrease or mitigate the market power of the traditional dealers. We must, notice the effect of how this kind of digital economy improving the profit opportunity of the industry rather than just to leave the profit on the middle side. And on the other side, I want to emphasize the role of government. The market failure always exists. And now we see in many digital industries, market concentration level is really high. Okay, in some sectors, only one or two very big companies occupy the whole industry. So that means they might have the opportunity to manipulate the market, to manipulate the matching process for high profit. But these kind of things hurt the industry and the consumers and also hurt the digital economy's competition. I want to say the government should figuring out a correct way to regulate the digital economy so the visible hand can guarantee the invisible hand really ensure the market efficiency.
Coming up next, China has already determined new ways to use computing power to bolster its economy, but fresh challenges are looming.
The key challenge is not the computing power itself. Can we figure out a way to build up efficient and reliable digital infrastructures?
Lagging but motivated, China is accelerating its bid for chip supremacy.
Together with CPU, could continuously provide more computing power with much less power consumption.
.360-degree profiles of industry movers and shakers, tech mavericks, and policymakers. We drill down on their success. We ask how they set strategy and how they navigate in an increasingly competitive market. Real talk, real business. Join the conversation. Biz Talk, only on CGTN.
Necessity is a mother of invention. China's boost in computing capacity is being met with growing needs. The NDRC estimates that China's demand for computing power will annually expand by more than 20% over the next several years. Such a growth rate is in line with China's 14th five-year plan for informatization. The Chinese State Council says that the core industries in the digital economy will account for 1/10 of its GDP by 2025. That's up from 7.8% in 2020 and signals that huge market space will become available. And Professor Yu, as China becomes one of the leaders in computing power, is there any responsibility or obligation that a country should shoulder?
China is the largest developing country who has already explored how to use the computing power to boom the economy. I think the first thing China should shoulder is that summarize the experience it has of using the digital economy to reach people, to industrialize their economy, to provide much better public good and public services. Mm-hmm. The second thing is about because we are the one, have very large computing power, that means we have a lot of experience about using computing power. We must understand we have the obligation of figuring out a new philosophy about regulating the computing power and the economic activities on that. As the largest developing country in the world, we should summarize how can a developing or underdeveloped economy figure out the first step for digital economy growth while protect the basic principles of human rights and other things.
These issues are very important in the digital economy era. And Mr. Zhang, computing power plays a very critical role in China's economic growth in the digital era. What is your company doing to facilitate the utilization of the power?
Issue is focusing on DPU, data processing unit design. Despite being relatively new, DPU is becoming one of the key processors to make data centers more power efficient and help meet the computing power need of processing even larger amount of data. A trend that is called Moore's Law. Basically, in 1975, Intel founder Gordon Moore predicted the regularity of the semiconductor miniaturization trend, which doubled the number of transistors on computer chips or processors every 2 years. That means exponential growth in computing power lasted for the past few decades. However, unfortunately, Moore's Law has been running out of steam as a viable way to grow computing power recently. By 2018, it showed a roughly 15-fold gap between Moore's Law prediction and current capability in performance. So comes the post-Moore's Law era. And in this era, processors created with the domain-specific architecture method are more efficient than traditional processors in different domains. And together with CPU, could continuously provide more computing power with much less power consumption. Actually, we have also seen this trend in the popularity of GPU, AI chips, and Bitcoin miner processors. Looking forward, DPU will be a key driver to revolutionizing the current computation infrastructure of data centers.
The development of AI seems to stretch the volume of data to infinity, enhancing the future of digital transformation. During the transition, however, computing power defines productivity. Its data processing capabilities will largely define the landscape of our future digital world. In a bid to take the nation's overall computing power to the next level, China recently approved the East Data and Western Computing Project. The effort will see the building of 8 computing hubs and 10 data center clusters across the country. And to many of us, computing power is a relatively abstract concept, and China's economic planners said computing power has already become an important infrastructure for national economic development. Professor, you help us understand this. How is computing power similar to the traditional infrastructure such as the railway?
When I say it is a new type of infrastructure, it is from the technical perspective and also the governance perspective or management perspective. From technical perspective, compared with traditional infrastructures like highway or railway, the computing power system need the high frequently operation. So the computing power operation need a lot of technologies and also ask for hiring a lot of engineers to maintain them daily. Okay, those engineers are very expensive and the government cannot afford for their salaries. We must rely on the market system to hiring those kind of engineers to operate and manage the computing power system. From the economic and governance perspective, how shall we organize the computing power market? That means the pricing design or market design for computing power allocation is a very sophisticated question. We cannot only, hands off and leave that kind of pricing system to the market themselves. The government should hands on the market design for that. This is the first argument. And also we noticed that, computing power now is mainly invested by private companies. Here I want to quote Professor Jiang Xiaojuan from Tsinghua University. She said, because control these kind of technologies and infrastructures, these giant companies have a new type of political power. So in this kind of situation, government should play the role to decide the rules of the computing power company or operators' behavior. If we say the railway companies or the power grid companies, we will find that the government have a lot of these kind of regulations, limit their behaviors and require them, guarantees a free access principle for the whole society. That means every people have the right to access to the infrastructure. Now we do not have sufficient regulations. We should really carefully research how shall we crack and efficiently regulate the computing power system.
Professor, the rise of AI is one of the major drivers of computing power demand. How is computing power shaping the future of AI, and how will AI improve computing power in the future?
I'd like to emphasize that according to our research, we have noticed that nowadays, the problem is they do not have sufficient computing power. The hot topic is how can we, simultaneously enable the artificial intelligence computing, but also protect the data security. Many computer scientists have focused on, using the cryptographic technologies or other computer science technologies to build up the system to enable the artificial intelligence ways information security. Those kind of system is called trustworthy computing environment. This is one type of infrastructure, digital infrastructure should be paired with. The point I would like to emphasize is, in the next era of artificial intelligence development, the key challenge is not the computing power itself. The key challenge is, can we figure out a way to build up efficient and reliable digital infrastructures can solve the troubles now suffering the artificial intelligence development, like the data privacy issue.
Coming up next, China launched the Eastern Data and Western Computing Project to balance the distribution of computing facilities.
This will greatly boost the new technology adaptation rate in data centers.
The mega plan is also part of China's efforts to achieve carbon neutrality.
On the western region, we have more cooling climate and more renewable energy. So lower price for the electricity.
Each day, there are millions of stories. Each one can open new perspectives, new possibilities. Wherever you look, we are there. To see, discover, explore. We put the pieces together to find what really matters to you, all around the world, all around the clock. Our reporters are at home across the globe. From our headquarters in Beijing and production centers in Washington, Nairobi, and London, China Global Television Network. Stories from across the globe, reaching people across the globe. CGTN. See the difference.
Over 90% of the people in China live in the country's eastern half, but most of the renewable energy resources are in the west. By channeling computing power from China's economic powerhouses to the western regions, the Eastern Data and Western Computing Project is expected to meet twin goals. One is to achieve a data-free flow at a national level, and the other is to make better use of the green power in western regions to advance China's low-carbon transition. Professor Yu, how will this new project accelerate the development of China's computing power and digital economy?
Before this kind of East Data, Western Computing project, the computing power center mainly concentrate on the east coast of China. If the government is absent from the market, the data center will still concentrate on the eastern region because of the history reason. However, when the government began to think about that kind of things, they find there's some opportunity. We rearrange the development opportunity in China, because nowadays we have the cloud technologies. That means the small startup companies can just rent the cloud rather than have their own computing power system. So on the other hand, on the western region, we have more cooling climate and more renewable energy. So lower price for the electricity. It is a new type of infrastructure.
Well, Mr. Zhang, from the perspective of the private sector, what potential and opportunity or even challenges will the new project unleash?
Yes, the project will unleash huge opportunities for computing power equipment providers or processor designers like Yushu. For example, currently, there are around 5 million server racks deployed today in data centers in China. And by the end of 2025, this number will become 18 million. It's more than 3 times growth within the next 5 years. Since many new data centers will be built from scratch in order to achieve carbon neutrality, these new data centers will most likely be equipped with the latest technology and types of equipment like DPU and others. This will greatly boost the new technology adaptation rate in data centers and help those companies or startups who have been focusing on tech innovation related to computer power infrastructure. I do see great opportunity and potentials for different kinds of companies, along the industry chain.
So by better utilizing renewable energy in the West, the project plays a key role in lowering the carbon footprint of computing. What more can be done to cut carbon dioxide emissions?
We know that renewable energy is intermittent and unpredictable, not well predictable. Okay, so in this situation, that means those computing tasks who can follow the renewable profile, renewable generations profile, they can consume less carbon. And on the other side, the computing task, which must require a very steady and the constant computing power, they are more carbon intensive. So from the carbon accounting perspective, we also need to develop some new matrix or new methodologies to evaluate the difference between different type of computing power tasks before we involve the whole business into the carbon trade program. So from the policy perspective, I think we still have a lot of things need to do before we regulate the carbon emission of this industry. But nevertheless, we should do something.
Along with the swift development of new technology, global demand for computing power is growing at an exponential rate. But CPU capacity isn't keeping pace. That means it is no longer following Moore's law of doubling every 2 years. To meet increasing complex computing needs, new type of processors such as GPU and DPU have been created. Each of the new processing units is designed to increase the ability to process massive amounts of data and drive efficiency at scale for data centers. And Mr. Zhang, what do you think are the trends setting the future demand of DPUs?
First, for the last few years, we witnessed exponential growth in the amount of data to be processed in the digital economy globally. According to the IDC data, we are expecting 163 zettabytes of data in 2025. And the data growth rate is actually catching up each year, especially in the new areas like autonomous driving, like 5G and edge computing, the industrial internet, VR, AR, or even metaverse. With so much data produced every day, the network bandwidth to move this data around also need to be increased exponentially. These are the I/O intense as well as data intense tasks mainly. So DPU is order of magnitude more efficient than CPU or GPU to process these kind of tasks. So we believe together with CPU, GPU, and DPU, we will have a much more balanced yet efficient computing infrastructure.
Mr. Zhang, your company is one of the many which are actually involved in building such infrastructure. Could you share with us what kind of infrastructure that you are building and why is it important?
Currently, for large data centers, 25G is the standard bandwidth for the network interface for servers in those data centers. Without DPU, processing I/O and virtualization at the speed of 25G has already consumed up to like 30 to 40% of the CPU's processing power. And with an exponential data growth rate, we are expecting the standard bandwidth in large data centers to be increased from 25G to 100G within the next 4 or 5 years. When it comes, CPU only won't be able to handle so much data at such a high speed. So basically, without DPU, all the computing power of CPU will be consumed just by moving data around, packaging and unpackaging data, stuff like that. Mm-hmm. So there won't be actual CPU power to actually process the data or complete algorithms like AI for meaning. Worldwide, all the major cloud services providers, such as Amazon, Microsoft, Alibaba, Tencent, and etc., have also deployed or been deploying DPU to their data centers.
Well, we have to leave it there. Thanks to both of you. Zhang Yu, Senior Vice President of User Technology, a data processor maker in China, and Yu Yan, Assistant Professor at the Institute for Interdisciplinary Information Sciences at Tsinghua University. So in the digital age, data and computing power have become driving forces of economic development. As one of the global leaders in computing power, China will speed up the construction of this new infrastructure and further tap into the immense potential of digital transformation. That will do it for this edition of BizTalk on CGTN. I'm Guanxing. See you next time.